The science of light. Light it up.
Whoa! Look at that! Science Club for Girls Live. Let's all take one deep dive into the world of science, technology, engineering, and math. Get your safety goggles, 'cause we're making things explode. Science is so fun, so let's take it on the road. Meet a young scientist just like you and learn all about what they do. We'll even learn science that's in the news through one-on-one interviews with SCFGLive and friends. Experimenting never ends. Now let's see what's in store. Just press play and get ready to explore. Ho, 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 hey, hey. Ho, 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 hey, hey, hey.
Hannah, where are you? I can't see you.
Sally, I'm over here. Hold on, let me turn the lights on.
Oh, what were you doing in the dark?
I was playing with light by making shadow puppets.
I've always wanted to make shadow puppets. Can you turn the lights back on so I could do one?
Sure, Sally. Hold on 1 second.
Oh, it's just my shadow. I have no hands. Oh, that's embarrassing. Can you turn the lights back on?
Sure.
Oh.
Sally, even though you didn't have hands, you made some pretty cool shadows using light.
Yeah, I did. You know, I love light and everything to do with light. It's all around us, in our houses, outside from the sun. It can be really, really bright, or it can be really dim from the candles. Oh, I just love light.
I do too. It's a super important thing that we have everywhere, just like you're saying, Sally.
Yeah, it's so important that I actually know some facts. Do you want to know some facts
I
about
would
light?
love to know some light facts. Please enlighten us, Sally.
So did you know that light travels 8 minutes from the sun to Earth? And also that light is a spectrum, and that's why there's so many colors. Each color is a different wavelength of light. Woo!
Okay, Sally, you're talking at the speed of light. We really need to slow down. I know you're excited.
Yeah, I'm just so excited for this episode. But we can learn more through experiments.
We sure can, Sally. In fact, I thought in this episode, why don't we talk more about light?
Yeah! Let's go!
Let's go!
Hey everybody! For this first experiment, we're going to be doing Newton's color wheel. It might be a little bit tricky at first, but we're going to get it together and understand color theory. For this project, you're going to need colored pencils, a piece of cardboard, paper, some wooden dowels or sticks, scissors, glue, tape, and some paint. Alright, for this first part of the experiment, what do we need for a color wheel? A circle, obviously. So first, I'm going to cut out a circle on my cardboard, then use that cardboard circle to trace a circle on my paper so they're the same size. Next part is that we're going to divide our piece of paper into 8 sections. How you're going to want to do this is by drawing a line down the middle, and I'll split it in half, and then we'll have 2 pieces. Then you're going to rotate it, do another line down the middle, then we'll have 4. We're going to keep doing that until we have 8. Now it's time to color. We're going to do it in the colors of the rainbow. Do you know Roy G. Biv? That's not a person. That's just the order of colors of the rainbow. We have red, orange, yellow, green, blue, indigo, and violet. Don't worry if you don't have indigo, just use purple. So now that we have our color wheel done, and don't worry, leave that one space to be white. We're gonna glue it on to our cardboard for our sturdy backing. And then we're gonna poke a hole in the middle for our wooden dowel so we can spin it around. Any predictions what might happen? All right, time to test out when this spins. What do you think is gonna happen? I think you're just gonna see the rainbow, honestly. All right, ready? Do you see that? It's kind of white. I know we could spin it on our own, but I want to see what happens when we can make it go faster. That's why I have this drill. Do not use a drill without your parents. Only your parents are allowed to use a drill. But I'm a scientist and an adult, so I can use this. 3, 2, 1. It kind of turned white, even though each one of them is a different color. Interesting. Whoa. That was kind of weird. Do you know why that happened? When I spin it around really fast, all the wavelengths are adding together. It's called additive color mixing. Each color has a different wavelength. Wavelength is just the measure of distance between two waves. So light sometimes acts as a wave. Red light has a longer wavelength than purple. So when we mix them all together, all the wavelengths are coming together to our eyes, and when they all get added together, it creates white. Now, you may be wondering why this doesn't happen with pink. Let's see what happens when we add all the colors together with pink. Now, you may be wondering why, when I mixed all the pinks together, it didn't turn white, just like with our other experiment. Instead, it turned brown or black. Well, this is called subtractive color mixing. You see, when we physically mix two different colors, they go on top of each other, and they're gonna block each other's wavelengths. Let me explain this a little bit further. You see this blue? We're seeing blue because all the light from the sun or any other light source has every wavelength in it. It has red wavelength, orange, yellow, green, blue, and purple. But when we see blue paint, it's reflecting back the blue wavelength only and absorbing all the other wavelengths. So it absorbs red, orange, yellow, and purple. Now red is reflecting back to us red, but that means it's also absorbing blue so that we can't see the blue. So now if the blue absorbs red and the red absorbs blue and we mix them together, they absorb each other's colors. So then it creates a new color like black or brown because the wavelengths of the blue and the red are both blocked. And so then we can't see those colors anymore. An easy way to remember the difference between additive color mixing and subtractive color mixing is additive is when we're mixing together light and different wavelengths and they don't block each other. You could see all of them. And subtractive is when we're mixing something more like solids like paints or markers or crayons and you're putting the wavelengths on top of each other, creating new color. All right, thanks, young scientist.
Scientists, I wanted to show you something cool that I just made. It's a dream house. I use different materials that are going to interact differently with light to make my house. Watch this. When I shine light on the roof of my house, the light is reflected back at you. That's because tinfoil or aluminum foil is a reflective material, meaning that light bounces off of it, right back to the person looking at it. Watch this though. When I shine my light through my tissue paper window, you can see a little bit of light, but not all of it. Tissue paper is a translucent material, meaning it lets a little light through, but not all of it. What about the wax paper window? Let's see. When I shine my light through the wax paper window, most of it goes right through. Wax paper is a transparent material, meaning it lets most of the light right through it. What about my cardboard door though? Let's see. Can you see any of the light coming through my cardboard door? I don't think so. That's because cardboard absorbs light, meaning it sucks it right in so no light can pass through. Well, I know my dream house wouldn't be complete without a pool. Take a look at this. Here's my pool. Let's see how light interacts with water. I'm gonna pretend like my pencil is going for a swim. Woo! Whoa, look at that. It almost looks like the pencil is bent in half as it enters the water. Water refracts light, meaning it bends those light waves. Very cool. Well, thanks, young scientists, for taking a look at my dream house and the ways that light interacts with different materials in the house. I challenge you to make your own dream house at home. Use different materials and see how light interacts with those materials. Have fun!
Hi, my name is Alicia and I'm in 6th grade. Today I'm going to show you how to make a kaleidoscope. A kaleidoscope is an optical illusion instrument that uses the power of reflection to make some pretty cool designs. Remember, reflection happens when a light ray hits a surface and bounces off. Certain objects reflect light pretty well, like mirrors and white paper. So today I'm going to be using an empty toilet paper roll, a mirrored sheet, scissors, tape, a white sheet of cardstock, a flexible bendy straw, a ruler, markers, stickers, things to design my spinning wheel with, and you can also use paint to design your cardboard tube, but this part is optional. So I'm going to start by designing my toilet paper roll. I'm not going to be using the paint, instead I'm going to be using my markers, but if you do use the paint, make sure you let it dry before moving on to the next steps. I think I'm just going to be using the yellow to design it. Okay, I've designed my cardboard tube. You probably can't see it, but I just put some yellow squiggly lines everywhere. Next, it's time to cut out your mirrored sheets into 3 equal strips. You want these strips to fit snugly inside your cardboard tube, so you should try to get them at 9.7 centimeters by 3.5 centimeters. I've already cut these out right here at the right measurements. Now you should lay down your strips all together and put the shiny side facing down. You want to tape the insides of the strips, leaving a bit of space in between that. So this is what it looks like once you've taped it inside. Now it's time to fold your triangle into a triangular prism, just like this. You should tape the top along the middle, but only there. Now you can put this up inside your tube. Just like that. Now you can cut off your straw, cutting where the bendy part is. You want to tape your straw along the top of it, leaving the bendy part over the edge. That bendy part on the top. Now it's time to cut out your 3 circles from your piece of cardstock. I've also already cut these out, and they should look like this at the end. To make sure you have the right size, the diameter of each of your circles should be about 3.75 inches. You can use your ruler to make sure it is. Now you want to poke holes in the middle of each of your circles. I'm just going to be using a pencil. You want to make sure the holes are big enough so that the straw can fit in it later. Once you have all of your circles like this, you can start decorating them. You can use markers, crayons, stickers, etc. I'm just going to be using markers and some stickers. To design them, you can make letters or patterns, anything like that. And here I wrote Alicia. Once you have your 3 templates, or spinning circles, you can try them out. So to do this, you put the straw inside the circle. If your circle isn't big enough, you can always put the pencil back in it and make it a bit bigger. Then once you look inside, you can spin your circle around and you'll see some pretty cool designs. You can try this out with each of your templates. So, that's how you make a kaleidoscope. Thank you for watching.
Wow, Sally, we sure did learn a lot about light in today's episode.
Yeah, light is all around us, and we don't think about all the things it can do, but it really does a lot, and there's so much science involved.
Yeah, like how we see color because of different wavelengths, and how when we combine wavelengths together, I like that you're being a wave, Sally, how when we combine wavelengths together, sometimes it can turn white, but not with paint. Something different happens with paint, which we also saw in our experiment.
Yeah, and also it was so cool to act out what it's like to be a photon. Did I say that right?
You did, nice work. We also saw how light interacts differently with different objects. Like sometimes light can pass right through something. In the case of glass, like our windows, or plastic wrap. Other times, light gets absorbed, like with cardboard. Or light can reflect right back at us, like with mirrors or aluminum foil.
Wow, we learned so much. Thank you, Hannah, for this episode.
For sure. Thanks for joining me, Sally. I hope I was able to enlighten you some more.
Yeah, you were. All right, thanks, young scientists. We'll see you next time.
Bye, everyone.
Bye.
This episode of SCFGLive has been brought to you by National Grid, who supports Science Club for Girls' mission in making STEM exciting and accessible to all. Both National Grid and Science Club for Girls support women in STEM and are working towards making STEM more diverse, equitable, and inclusive. Science Club for Girls is a nonprofit organization that fosters excitement, confidence, and literacy in STEM for girls and young women from underrepresented communities with free experiential community-based programs. To help keep our programs free, please consider making a donation today. Learn more and donate at scienceclubforgirls.org.